So hello guys, now we are starting with the lecture number 3 of this aldehyde and ketone series. So in lecture number 2 I have discussed with you the method of preparations that are valid for aldehyde and ketones. Like both aldehyde and ketones we can prepare by those methods, right? But now we are discussing the specific methods that are preparation for aldehydes only, right guys? And this is also quite important topic, okay? So in method of preparation, the second heading is method of preparation for aldehyde only. Method of preparation for aldehydes only. Okay, only aldehydes. Method of preparation for aldehyde only. Right? Like only we can prepare aldehyde. We can't prepare ketones with these methods, and they are quite important methods. Okay, so the A is, or let's say first method is guys very important, that is Rosenmund reduction. First method is Rosenmund reduction. Okay, so first one is our Rosenmund reduction. So what is Rosenmund reduction? So I will explain this to you, right? So suppose this is this particular group, functional group, we call this acyl chloride, or acid chloride would be the better name, right? We call it acid chloride. Acid chloride. Okay, so let me tell you one important thing here, that if you will do its reaction with, if you will do its hydrogenation with nickel, platinum and Pd. Okay, we learned about these reductions with the hydrogen, nickel, platinum, palladium. If you will do that for acid, then acid will change into alcohol, if you remember, right? So when you do this reduction, this is basically reduction, okay, reducing agent. So if you will do that, then we will get what? We will get RCH2OH. We will get alcohol. If you will do its reduction directly with H2PT, H2NiPT/PD, we will get what? Alcohol. Now in Rosenmund reduction, what we do basically in Rosenmund reduction, okay, basically what we do, we will do its reaction with, let me write like this, we will do its reaction with H2, okay, but yes, H2 and like this PDBaSO4. This is how we will write H2PDBaSO4, right? H2PDBaSO4. This is, the catalyst name is Lindlar catalyst. We call it Lindlar catalyst. Okay. So now what is the difference here? Okay, slash means either you can use palladium or you can use nickel or platinum, right? Now I'm using H2, okay, hydrogenation. I'm using palladium as a metal and I'm using barium sulfate. So what happens? A magic will happen here. And what is the magic? That instead of getting alcohol, what we will get? We will get alcohol. Instead of getting alcohol, sorry, we will get what? Aldehyde. We will get aldehyde. Okay, so what kind of magic is this? Why we are getting aldehyde? Okay, so let me tell you, this particular reaction, when acid chloride reacts with H2PDBaSO4, this particular reaction is known as Rosenmund. This particular reaction is known as Rosenmund reduction. Okay, now why we are getting aldehyde instead of alcohol, right? So guys, okay, so what we are basically doing, what is the meaning of BaSO4? So suppose this is your palladium metal, this is your PD metal. Okay, so what is the, like, what kind of hydrogenation is this? That what happens, that H2 gas will absorb on the surface of platinum. Okay, like H2 gas will absorb on the surface of platinum, and then this reaction will trigger, and we will get what? We will get what? Alcohol. So let me tell you, if enough hydrogen will deposit on the palladium surface, enough hydrogen, then what product we will get? We will get alcohol product. We will get alcohol product, right? But suppose if you will decrease the content of hydrogen adsorb on platinum, then instead of alcohol, this reaction will stop at only at aldehyde. It will not further go to alcohol. So in order to reduce the adsorbed content on palladium, what basically we do, guys? So we do very important, very magical thing here. Basically, what we do, we put BaSO4 on its surface like this. Suppose this is BaSO4. Okay, we put what? BaSO4 on the surface of catalyst. Basically, it's a paste type of thing, right? Suppose this is my palladium metal. So what I will do, I will add BaSO4 over it. I will cover the metal surface with BaSO4. So what will happen? Yes, hydrogen will to adsorb. These metals have very high tendency to adsorb hydrogen gas. Yes, hydrogen will adsorb, but the content of hydrogen or the amount of hydrogen that will adsorb will be less, right? So basically what you did by applying BaSO4 paste or BaSO4 powder on palladium metal, what you did basically, palladium, nickel, platinum and palladium, they are behaving as a catalyst here, right? So basically you reduced the reactivity of catalyst, because now less hydrogen is being adsorbed. So if less hydrogen, then instead of getting alcohol, this reaction will stop at aldehyde only. Understood? So basically applying BaSO4 on the surface of catalyst, on the surface of palladium, basically this is known as poisoning. This is known as poisoning of catalyst. This is known as poisoning of catalyst. This is known as what, guys? Poisoning of catalyst. And why we do the poisoning? To decrease the reactivity of catalyst. Okay, and this particular reaction is known as what? Rosenmond reduction. Okay, so I'm again repeating myself. If you will do the reaction of acid chloride with H2NiPtPd without BaSO4, then you will get final product alcohol. But right now, if you will poison the catalyst means if you will apply the paste of BaSO4 on the surface of palladium, okay, then what will happen? The amount of hydrogen adsorbed will be less, and because of this, instead of getting alcohol, we will get aldehyde. Because aldehyde can further be reduced to alcohol, but we will get aldehyde only because we decrease the reactivity of catalyst by poisoning it, or by applying the paste, poisoning of catalyst by applying the paste of BaSO4 on the palladium surface. Understood? And this is known as, this particular reaction is known as Rosenmond reduction. Okay, guys, so what kind of questions can be asked? So let me tell you. Suppose we have this. Okay, this is known as benzoyl chloride. This is known as benzoyl chloride, right? So if you will do the reaction of benzoyl chloride with H2PdBaSO4, okay, so you have to identify, okay, this is acid chloride, right? So H2PdB, I would get alcohol, but now we are doing the poisoning. So instead of getting alcohol, this whole group CuCl, this whole group will change into CHO. So what I will get? I will get benzaldehyde. I will guys get what? I will guys get benzaldehyde. Understood? Clear? Okay. Similarly, second type of question. Tell me the answer. CH3, CH2, C double bond O, Cl. Okay. If I will do its reaction with, suppose if I am doing its reaction with H2NiPtPd. No poisoning. So then what I will get? I will get alcohol, CH3, CH2, CH2OH. Okay. But if I will do Rosenmond reduction means poisoning with PdBaSO4. H2 with PdBaSO4. Sulfur and even quinoline we can also use, but in NCERT BaSO4 is given. Okay. BaSO4. So what I will get? I will get CH3, CH2, okay, and CHO. I will get aldehyde. Understood, guys? So this is your very basic reaction, Rosenmond reduction. Okay, and even in your school exam they directly ask this Rosenmond reduction, right? Then define Rosenmond reduction, or they will give you this reaction and convert into benzaldehyde. So can you do that? It's very easy, right? Okay, so this is the first method, and this method you can only with the help of this method you can only obtain aldehydes. It's not valid for ketones. Understood? So that's it. This is your Rosenmond reduction. Okay, question भी हो गया अपने पास. Okay, now the second is okay. So after this, second is very important. Second method is very important. Okay. From diamond reaction of from by reduction with very important, guys. By reduction with diol H. Okay, by reduction with diol H. By reduction with diol H. Okay, so first of all, let me tell you what is diol H. Diol H is diisobutyl aluminium hydride. Diisobutyl aluminium hydride. This is your diol H. Okay, diisobutyl aluminium hydride, and even the structure of this is like this, isobutyl. So like this. Okay, and there is one hydrogen here, and it has vacant orbital like this. Okay, this is the vacant orbital, diol H, and even you will find this like this also. Sometimes they write like this, AlH aluminum hydride diisobutyl, AlH, okay, IbO2, isobutyl, right? So this is your diol H. It is very important reducing agent, very important reducing agent, diol H. Understood? So for like reducing agent, we have lithium aluminum hydride, sodium borohydride, H2Ni, PTPD. They all are reducing agent. So yes, reducing agent. So I told you in alcohol also, but yes, even in carbonyl compound there is a different topic, reduction of carbonyl compound. So there we will see in more detail. But right now my focus is on diol H. So basically, guys, what happens that with reducing agent you have to remember that which kind of functional group they reduce. That you have to remember. So for diol H, basically I created a one kind of trick basically to memorize diol H. Otherwise, basically you will forget it. Otherwise, after some time you will forget it that what diol H do. So okay, so for diol H you remember this trick. ABCE. Trick is ABCE. Okay, like this. Trick is like ACE, okay, like you write this trick, okay, ACE. The trick is ACE. Okay, ABCE, or like the trick is ACE. For diol H, the trick is ACE, right? So what happens in ACE? Like these days, so ACE is so very famous also, right? Many students know like what is ACE, diamond, right? ACE. Okay, like ACE is, so basically what this do. It convert C for cyanide. It converts cyanide to aldehyde. It converts ester to aldehyde. It only reduces two functional group, cyanide and esters, right? That is very important. So like, yes, you are like, sir, what is this? This seems stupid, right? ACE, what is ACE? But mnemonics will help you to memorize the stuff for a long term, right? Right now, okay, sir, we will to remember it. It will convert cyanide to aldehyde, ester to aldehyde. But after some time, you will forget. That will happen for sure, right? That's why trick for diol H. Diol H, whenever you see diol H, ACE. ACE means what? ACE means, the trick is ACE, right? So ACE is, this is your cyanide. and this is your ester. Okay, so basically what it do, it convert all of them. We can only get aldehyde. It converts cyanide to ester. Cyanide to aldehyde, sorry, and it convert ester to aldehyde. Okay, so this is the trick for dival H. Trick is ACE. Okay, cyanide to aldehyde, ester to aldehyde. Cyanide to aldehyde, ester to aldehyde. Okay, the trick is ACE. So let me tell you, okay, like how. So example is, like, let's say this is our question number 1. Okay, so I'm writing the questions. So the question is, let's say we have CS3 CH, CS3 CH, double bond CH, CH2, CH2 and CN. Okay, now I'm doing its reaction with like this: ALH, isobutyl, and second step is water. Okay, so ALH isobutyl. First of all, so you don't have to be scared that what is this? Arey, this is to dival H. Okay, sir, no problem. Cyanide to aldehyde. Basically, what you are going to do? You are going to put this group CN change to CHO. That's it. That is what you are going to do. You will convert CN to CHO. So what will be my answer? Nothing will happen to double bond. Okay, it will not reduce double bond. CH, CH2, CH2, and simply CHO. Aage apna answer. Right? So dival H trick is ACE. Cyanide to aldehyde, ester to aldehyde. So this is the first one is your cyanide. First one is your cyanide group. Okay. Now the second one is ester. So like CS3 CH2 C double bond O. Okay, C double bond O CH, C double bond O oxygen and CS3. Okay, so again I'm doing its reaction with dival H. First step and second step is hydrolysis. Okay, again क्या है ये? This is ester. Okay, RCOOR. This is ester group. So basically it also convert ester group to aldehyde. Okay, so this part will change into this COO part will change into CHO part. Okay, this COO will change into CHO. So what I will get? I will get CS3 CH2 CHO propanol plus this part will change into alcohol. Okay, so I will get HOCH3. Okay, I will write general reaction also, like if you are finding any kind of difficulty, right? So this is your answer. One you will get alcohol and one you will get what? One you will get alcohol and one you will get aldehyde. One you will get aldehyde. Okay, so this is your dival H, diisobutyl aluminum hydride. It's a reducing agent, and what kind of functional group? What kind of functional group it reduce? It reduce, guys. What kind of functional group it reduce? It reduce ACE. ACE. Aldehyde banega from ester to aldehyde, cyanide to aldehyde. ACE. Trick is ACE. Okay, done. Clear? So many students are like, sir, thoda ester ka we have little doubt. Can you clarify? Okay, I know your doubts, right? So I'm just writing that also. Okay, so you tell me what is the general functional group ester? R dash O R dash R COO R dash. So if you are doing its reaction with dival H, and in second step you are doing it hydrolysis. Okay, what product? Listen. Basically, it goes out like this. H and इसको ऐसे छोड़ दो. Basically, remove this bond and put HH. Okay, so what we will get? RCOOH plus R dash OH. Okay, so this is your aldehyde, this is your aldehyde, and this is your alcohol. Understood? So I hope the reaction with dival H is clear to you. Reaction with dival H is very much clear, right? So what is the definition of dival H? That is clear to us, and ACE is the trick. What kind of function group it will reduce. Okay, so this is your reduction with dival H. Now the third is very important name reaction, very important for your school exam also. Okay, so that is Stephens. Third one is Stephens. Third one is Stephens reduction. third one is Stefan's reduction. Okay, so what is Stefan's reduction? So very important name reaction. Okay, this is cyanide. Alkyl nitrile is IUPAC name. Okay, and we call them cyanides. Okay, alkyl nitrile. So if you will do their reaction, direct question, define Stefan's reaction and write the reaction. If you will do their reaction with SnCl2 plus HCl, okay, what we are doing, if you are doing their reaction with SnCl2 plus HCl, first of all they convert into RCH double bond NH, we call it imine, and on hydrolysis H plus and H2O, we will get what? RCHO. What we will get, guys? We will get RCHO plus ammonia gas. Okay, RCHO plus ammonia gas. This is known as aldehyde. This is aldehyde, and this is your Stefan's reduction. Very important name reaction from aldehyde and ketones. Stefan's reduction. Okay, let's say I'm giving you one example from, I'm including aldehyde also, like alkyl halide also. So let's see. Suppose we have CS3 CH2. Okay, let's say we have alkane. We did its reaction with Cl2H. First step, halogenation of alkane. A product. Then we are doing its further reaction with KCN. B product. The third reaction we are doing it with, first step we are doing SnCl2 slash HCl, and second step hydrolysis. I am asking you what is A, what is B, and what is C. So what you are going to do? Chlorination, do you know? Remove any hydrogen with chlorine. I discussed everything, right? CH3, CH2, Cl. What about KCN? Okay, 1 degree halide. Cn minus is your nucleophile, ambient nucleophile, can attack from carbon and nitrogen, but this compound is ionic, so nitrogen is a better, carbon is a better donor site here, because if you will write the structure, then this is the structure of Cn minus. Okay, so carbon is a better donor site here because it has negative charge, so it will attach, and what we will get, we discussed all of this in alkyl, haloalkanes and halogenes. We will get alkyl nitrile, Cn. Now, what will happen to the Cn? Tell me, Stephan will change Cn into CHO along with the formation of ammonia gas. Okay, so these kind of questions can be asked in your different kind of exams, right, guys? Okay, so this is your Stephan's reduction. So first method that we discussed is Rosenwald reduction. Second method we discussed reduction with dimer H, and the third method that we discussed is Stephan's reduction. Understood? Clear? So by doing these methods we can get aldehydes. By doing these methods we can get aldehydes. Understood, guys? Clear? I don't think there has to be any doubt now. Okay, so next one is from hydrocarbons. Third method was Stephan's reduction. Now we have fourth method, that is from hydrocarbons. Fourth method is from hydrocarbons. Okay, so this is also very important, and I will discuss so many important things here. Okay, so first of all, suppose this is your toluene. Maximum of you to know already, but yes, still I am telling you. And if you will do its reaction with strong oxidizing agent, like if you will do its reaction with alkaline KMnO4, suppose if you do its reaction with alkaline KMnO4, or acidified K2Cr2O7, if you will do its reaction with alkaline KMnO4 or acidified K2Cr2O7. So let me tell you one trick here, that this carbon is known as benzylic carbon. Carbon that is attached to the benzene ring is known as benzylic carbon. This is known as benzylic carbon. Okay, and hydrogen attached to it. Okay, these hydrogens are known as benzylic hydrogen. These hydrogens are known as what? Benzylic hydrogen. So the trick is basically, if the derivative of benzene like toluene is there, right? Okay, ethyl benzene is there. If the derivative of benzene contain at least one alpha hydrogen, at least one benzylic hydrogen, then the whole group will change into, on reaction with strong oxidizing agent, whole group will change into COH. Whole group will change into what, guys? COOH. Very, very important, right? Not only this, suppose if I am writing ethyl benzene, so what will happen if you will do its reaction with same alkaline KMnO4 and acidified K2Cl2? What you will write? So you are like, okay, derivative of benzene and strong oxidizing agent. Okay, this is benzylic carbon. It contains benzylic hydrogen or not? Yes, it has to. So what will happen to the whole group? This whole group, no matter how many carbon atoms are there, this whole group will change into, guys, what? This whole group will change into acid, benzoic acid. Understood? With strong oxidizing agent, the whole group will change into what? A benzoic acid, right? Now, I don't want acid. Acid to be want in the next chapter, that is carboxylic acid. I don't want acid. I want aldehyde. I want to stop this reaction at aldehyde or ketonic or ketone, right? So it means instead of these are the strong, if I will use mild, remember alcohol ka strong ke saath we get acid, but if you do mild, then you will get aldehyde and ketone intermediate products, right? So I want to stop this reaction to aldehyde only. So basically, so for them we will use mild oxidizing agent. We will use mild oxidizing agent. Okay, so what are they? Let's see. We will use mild oxidizing agent. So mild oxidizing agent like CrO2Cl2, chromyl chloride, okay, and we will use chromium trioxide with acetic anhydride. Chromium trioxide with acetic anhydride. Okay, chromium trioxide with acetic anhydride. Okay, so they all are mild oxidizing agent. Mild oxidizing agent means when you will do the oxidation of aromatic hydrocarbons, then instead of getting acid, you will get what? You will get aldehyde. So we will see that what is the meaning of that, right? So suppose we have toluene, and for toluene I am doing its reaction with CrO2 Cl2 in first step, chromyl chloride, and in second step basically the medium is not a second step, the medium is non-polar like CH2, carbon disulfide. Okay, CrO2 Cl2 and CH2. Okay, so what happens basically, guys, in this reaction? First it will convert it into HCl2 twice. This complex you have to memorize. Mechanism so we will not do because it's not given in NCERT, right? This compound will form, and this is basically chromium complex. This is chromium complex, and if you will do its further hydrolysis, okay, then we will get benzaldehyde. Then we will get what, guys? Benzaldehyde. Okay, and let me tell you that this given reaction is a very, very important reaction for you. Okay, we are not getting acid. What we are getting? Benzaldehyde. This is very, very important reaction for your school exam, because this is name reaction. CrO2 Cl2 CH2. One first to chromium complex, you have to memorize this chromium complex. CHOCrOHCl2 twice. CHOCrOHCl2 twice. Okay. So and then further hydrolysis benzaldehyde. And this particular reaction is very, very important reaction. We call this Itard's reaction. What we call it? Itard's reaction. Okay, so yes, 1 mark question, write Itard's reaction, So this is your Itard's reaction. Okay, Itard's reaction. This one is your Itard's reaction. Understood? Okay. So when you do the mild oxidation, suppose if it would be alkaline KMnO4, then I will get benzoic acid. Now I am getting aldehyde. That's why this CrO2, Cl2 and CS2 is your mild oxidizing agent. Clear? Okay. And this particular reaction is known as Itard's reaction. Okay. So again, we did with CrO2, Cl2. Chromyl chloride. Now we will do with chromium. We will do with chromium trioxide. Okay, in the presence of acetic anhydride. So next is if you have toluene, and if you will do its reaction with chromium trioxide in acetic anhydride. This is acetic anhydride. CS3 CO twice. If reaction temperature is 273 to 283 Kelvin. Okay, 273 to 283 Kelvin. So again, final product is to benzaldehyde, but still, yeah, we have to memorize the intermediate product also. Okay, so that will be CHO CO CS3 twice. Okay, and if you will do it further hydrolysis and heating, then it will convert into benzaldehyde. Okay, so yes, you have to remember the intermediate products, but if you don't want to, suppose in your exam time you forgot this, what is the intermediate product? Because mechanism will be quite lengthy, so mechanisms, no point of doing that. So if you will able to remember, then it is okay, but if you forget, then write the major product, CHO directly, no problem, right? Benzaldehyde. Now you are at the mercy of the examiner, that whether it will accept it, that whether he or she will accept it or not. Okay, but yes, you will get some marks. They can't get the whole marks, right? So final product is benzaldehyde. So I hope you learned it that okay, if you will do with strong oxidizing agent, then you will get acid, but you will do with mild oxidizing agent. So intermediate products, will generally finally convert into what? Benzaldehyde. It will convert into, guys, what? It will convert it into benzaldehyde. Okay, and next one is, so this is your with CrO3 and CS acetic anhydride, but Itard's reaction with CrO2, Cl2 and CS2. That is your Itard's reaction. This is your Itard's reaction. Okay, guys, understood? So this was your fourth point with mild oxidation of aromatic hydrocarbons with mild oxidizing agent. That is Itard's, and one is with chromium trioxide and acetic anhydride. Okay. Now the fifth one is sidechain oxidation. Fifth one is sidechain oxidation. This is also very interesting and very easy also. Okay. Suppose this is toluene. Okay. And I am doing this reaction with Cl2 and HNO. If you remember, then I told in that case radical mechanism will go and suppose चलो इसका Br2 बना दो, चलो Cl2H2, ठीक है? Basically benzylic halogenation will takes place. Benzylic halogenation means you remove hydrogen with chlorine, like say CH2, Cl2. Suppose one more time. So what we will get? CH, Cl and Cl. Okay. Then if you will do its further reaction with aqueous KOH. You tell me, this is alkyl halide, this is aqueous KOH. Substitution होगा and OH बन जाएगा अपने पास by SN1 reaction. CHOH, OH. You know that carbon doesn't like two OH groups. What happens? Water release. Minus H2O, and what we will get? We will get CHO. That is benzaldehyde. Okay, understood? Clear? So that is your side chain. That is your, guys, what? That is your side chain oxidation. That is your side chain oxidation. And we will get what? We will get benzaldehyde. And the last one is Gatterman-Koch reaction. Last one is Gatterman-Koch reaction. So what is your Gatterman-Koch reaction? This is your benzene and we do its reaction with CO plus HCl. CO plus HCl in the presence of anhydrous AlCl3. This is also one type of electrophilic substitution reaction of benzene. So what we will get here, CHO, we will add CHO, add CHO, add CHO. Okay, so what we will get? Benzene, and above benzene we will get one CHO group. Okay, so this is your benzaldehyde and this is your Gatterman-Koch reaction. Okay, so these name reaction, this is also a name reaction, so it is also an important one. Okay, so that's it. These are the method of preparation of aldehydes only, right? So first, what is the first method that we discussed? Rosenmund reduction, then reduction with dimethyl H, then Stefan's reduction, then retards, then CRO, then chromium trioxide, acetic anhydride, then sidechain oxidation, then Gatterman-Koch reaction. Clear? Okay, so now the last thing is left for this particular lecture, then I will wrap up this lecture, that is method of preparation of ketones only. Okay, only ketones. So how we can get ketones? Okay, that is what we are going to discuss now. So the next is method of preparation of ketones only. Ketones only. Okay. Method of preparation of ketones only. So what are they? So first of all, so this method. What is this? Suppose this is your Grignard reagent, RMGX. This is Grignard reagent. Okay, so we will do its reaction with cadmium chloride. Cadmium chloride. Okay, so these are the type of reactions that you have to learn. There is no other way around. There is nothing to understand in them, right? Okay, you have to learn this reaction. So Grignard reagent, cadmium chloride. So what we will get? We will get R2CD plus MgX and Cl. Okay, so we will get dialkyl cadmium. We will get dialkyl cadmium, right? Then in next step, what we will do? We will take this dialkyl cadmium and we will do its reaction with 2 moles of acyl chloride or acid chloride. Acid chloride. Okay, and what will happen, guys? From here CdCl2 will get out. We will get CdCl2 and we will get 2 moles of ketone along with the formation of CdCl2. Along with the formation of what? Along with the formation of CdCl2, right? So by this method also we can prepare ketone. Okay, the Grignard reagent, cadmium chloride, this is step 1. In step 2, acid chloride plus dialkyl cadmium will give you ketone. Second method is from nitrile. So suppose we have CS3C triple bond N. Okay, let me write. We have CS3C triple bond N, and I am doing its reaction with R-MgX in first step. Pay attention now. Okay, so what will happen? If you remember, so I told you that for Grignard reagent, this is delta plus charge and this is delta minus. This is R minus. It can behave as a nucleophile or it can behave as a base. This bond is polar, so minus here, plus here. This R will attack over here, and this plus will attack over here. What we will get? RC. Okay, here we will get R dash RC R dash, right? Then we will get double bond N, okay, and MgX. Okay, so this is plus and this is minus, let's say. Okay guys, now in next step what we are going to do, it's hydrolysis. Okay, so basically for hydrolysis I will tell you the trick also. Like you do like this. This is H and this is OH. Basically like this. The ketone chair, so O, H and H. Okay, so more of electronegative will go with less electronegative, like this. Okay, so what I will get? I will get RC double bond O R dash, that is ketone, plus I will get, guys. Okay, so main product is to ketone, right? Main product is to ketone. Okay, and next I will get MgX and NH2. This is the product. Okay, so by doing the reaction of nitrize with Grignard reagent also followed by hydrolysis, you can get what? You can get ketone also. Right? So guys, basically these reactions, I can't help you much in this reaction. There is nothing to understand. So these reactions, so by writing, you have to practice these reactions. Okay, so just take the notes and then keep on practicing them, keep on revising them. These kind of things required a proper revision, right guys? Okay, and the last reaction that is we use for method of preparation of ketone only is, guys, Friedel-Crafts. This to be discussed so many times. Friedel-Crafts acylation. Okay, Friedel-Crafts acylation. So what is your Friedel-Crafts acylation, guys? So Friedel-Crafts acylation is this. I think everyone knows that, right? Benzene. Okay, acyl, CH3 C double bond O Cl. Then anhydrous AlCl3. Electrophilic substitution reaction of benzene. So basically in this reaction you have to think about the electrophile. So this acts as a Lewis acid, so it will generate this as an electrophile. Okay, Cl bond will break and this will be generated as electrophile. Now this will attack on a benzene. Okay, mechanism, so we are not going to discuss. No one is going to ask that, right? So we will get what this compound name is. We discussed common name is acetophenone. We will get what? Acetophenone. Right guys, acetophenone. Now suppose if I am doing its further reaction with conc H2SO4 plus concentrated HNO3. Okay, so basically you know that this is the nitration. Meaning of what? This is the nitration. We have to add NO2 basically, right? But now benzene is not free, benzene is substituted. Who's ruling over benzene? This COOCH3. So now this group will decide that NO2 where it can come. So I told you that if the element that is attached to the benzene ring has multiple bond, so this will have minus R effect. Minus R or minus M. And what they are basically, what kind of directing they are for electrophilic substitution? They are meta-directing. Their directive influence is meta. So the incoming electrophile will attach at meta position. So yes, I can extend this question to this also, right? So at meta position we will get what? We will get what? NO2 group. Okay, but yes, we are comparing the method of preparation of ketone. So by doing this, I can get the ketone. Understood? Okay, and the next thing is for us is, guys, okay, even I can do acylation with this also. Don't be confused. CH3COO twice. Okay, and anhydrous AlCl3. This is also acylation. But yes, here we have acetic anhydride. So many students can't write the product for this. They are scared. What is this? So let me tell you from here also, the electrophile that we will get, basically the cleavage of this bond will happen. Okay, and what we will get, this will be the electrophile. Same electrophile you will get. So same thing will attach attach over the benzene ring, and you will get again same product. What product you will get? You will get acetophenone. You will get acetophenone. Understood? Okay. This is also a acylation, but with what? What is the name of this compound? With what? Acetic anhydride. With what, guys? Acetic anhydride. Done? Clear? Okay. So these are the method of preparation of aldehydes and ketones. Okay, aldehyde and ketones are covered. So in this lecture we discussed every method, right? So in the next lecture, now I'm starting the most conceptual part of aldehyde and ketone, that is chemical reaction, nucleophilic addition reaction, aldol condensation, Cannizzaro, everything we are going to see. Okay, so thank you, and whatever the questions are given in NCERT, 1 minute. So that we will cover in the next class. Okay, in next I will start with some questions. Okay, so thank you very much. This is it.